All right, this is probably going to be a long one, but we're going to talk about how to properly collect data. Let's get to it. So first, we're going to talk about sampling methods, and we're going to talk about types of bias, talk about experimental design, what factors, levels, and treatments are, and scope of inference. So biased sampling methods. So these are bad ones. We don't like these ones, but we need to be aware of them. Voluntary response samples. Those are awful because the only people that are ever going to respond are people that have a huge interest in this, either positively or negatively. So that's going to lead to a biased result. Convenience samples are also bad because that's basically just saying I'm taking the next 10 people that walk this way. Because the next 10 people that walk this way have a reason to be there at that time. So you're not getting information about your entire population because of that. So these are better sampling methods. The cluster random sample. It's not ideal, but it is very convenient. That's the huge advantage to a cluster random sample. We choose a few random groups from a population. Usually we do this geographically. So maybe we break a county down by its zip codes or something like that. And we'll sample everybody in those groups. So there's still some randomness, but what if I happen to select all the rich neighborhoods? Then I end up getting biased results again. This is better because we've introduced randomization. It's super convenient, but it's still not the best thing we can do. Systematic random sampling, that's another one we could do if I just take like every 10th person. I've got a more detailed description of it down there in the slide, but basically it's just I took every 10th person and I started randomly. Also not ideal because it's kind of like just a random convenience sample, but better than it was. Preferred sampling methods, these are good ones. Simple random sample, this is the most typical one. Now it's not that everybody has the same chance of being selected. It's every possible sample has the same chance of being selected. So if I'm selecting 10 people, I have the same chance of getting like 10 20-year-olds that I do of 10 people with completely random ages, completely distributed ages. So simple random sample, that's our most basic one. The stratified random sample, this is a really good one. If you have a reason to believe that the population should be broken up by groups, maybe like freshman, sophomore, junior, senior, if you have a reason to believe that, then it's really good to do random sampling within each of those groups. That's going to reduce some of your sampling variability, which is a good thing because that means that your guesses are going to be more consistent. Your estimates will be more consistent. So stratified random sample, you break it down for some good reason and sample a few within each group. People confuse that with cluster sampling a lot, so make sure you're careful on that. All right, types of bias, we got the non-response bias. That occurs when people in a survey just don't respond. We don't like that, but there's not really a whole lot we can do about it because it's not like we can pin them down and make them respond. Response bias occurs when participants in a survey lie, and they might not do it because they're like just jerks that like to lie. Maybe they genuinely don't know the correct answer, or they think they do. But more often than not, it is because they're just jerks and they're lying. They have a reason to lie. So maybe like someone's asking your weight and you don't want to offer that up, or you're asking an older person their age and they don't want to tell you how old they are. So or the biggest one, if you're at a doctor's office and they say, do you smoke? Do you drink? And you don't want the doctor to think you're unhealthy, which is crazy because that's kind of the doctor's job to make sure that you are healthy. But anyway, under coverage bias, it occurs when some members of the population cannot or are less likely to be included in the survey. Examples of that, email. So if I do a survey only by email, anyone that doesn't have an email address or regular access to a computer, they can't be included in the survey. Or same thing with like landline telephones. We don't want to call just landline telephones because a lot of people don't have them anymore. Factors, levels, and treatments. So factors are the explanatory variables. If we only have one explanatory variable, we just usually say explanatory variable. But if there's more than one, we start to say factor. The different values that a factor take on, those are called levels. And the combination of all factors and levels then becomes the treatments. So the example I always give is when baking cookies, you might have two factors of temperature and time. Maybe we got two temperatures of 350 and 375, and then I've got 9 minutes versus 10 minutes. So the factors are temperature and time. The levels for temperature are 350 and 375. The levels for time are 9 minutes and 10 minutes. The treatment might be 350 degrees at 9 minutes or 350 degrees at 10 minutes, something like that. That's the difference between factors, levels, and treatments. All right, experimental design, we like to do those design diagrams. Remember, we would take the sample, randomly assign them, into our treatments, and then afterwards we compare results. So T1, T2, maybe there's more than one treatment, and then after that we compare. So when asked to design a study, this is the easiest way to do it. Make sure that you're talking about random assignment. Make sure you include that. Also describe how you would do that random assignment. You can't just say, I'm going to randomly assign them. You need to show them that you know how to do that. Completely randomized design would be the experimental units are randomly assigned to their treatment groups and you don't do anything else. That's it. You just, oh, look, I got a sample. Let me randomly assign them. That's what a completely randomized design is. A block design, that's kind of like the experimental design version of stratification. So maybe I've got my sample. I got here a nice little sample. And then I split it. The most common one that we divide by is gender. Especially because in like medical studies, gender is very important. But I've got my sample and I split it into men and women before I do my random assignment. So that's what blocking is, very much like stratification for random sampling. Matched pairs blocking is a special type of blocking where the blocks are all of size 2. And you're comparing two individuals directly. And you're going to compare their results directly rather than one whole group and one whole group. Confounding, this is a thing that we got to watch out for. Confounding variables are variables that haven't been accounted for that could be influencing the results. So the example that I like to use, morbid as it may be, is during the summer, both ice cream consumption and drowning deaths go up. But if I make a scatter plot of ice cream deaths and drowning, or not ice cream deaths, but ice cream consumption and drowning, it's going to look like they're related, but there's a confounding variable of summer that I haven't accounted for. A good experiment's going to control for as many variables as possible, but you're not going to be able to control everything. Randomness is a big part of helping control confounding as well. Scope of inference, this table's a little messy, but basically random assignment gives us inference about the population, right? Random selection, so randomly selected. If the answer is yes, they were randomly selected, then you can make inferences about the population. Were they randomly assigned to groups? If the answer is yes, then you can make inference about cause and effect. If the answer is no, then you cannot make inference about cause and effect. So random assignment gives cause and effect, random selection gives inference about the population. A bank surveyed all of its 60 employees to determine the proportion who participate in volunteer activities. Which of the following statements is true? The bank should not use the data from the survey because this is an observational study. You can use data from an observational study. It happens all the time. I won't be able to get cause and effect, but that's fine. The bank can use the result of this survey to prove that the working for this bank causes employees to participate in volunteer activities. Well, they didn't do random assignment, so I'm going to go no. The bank did not select a random sample of employees, so the survey will not provide the bank with useful information. It selected all of them. I think this information is going to be useful. The bank would have to use survey data to construct a confidence interval in order to estimate the proportion of employees who participate in volunteer activities. No, because they talked to all of them. You know the value. You don't need to do inference, which is what E is saying. The bank does not need to use an inference procedure to determine the proportion of employees who participate in volunteer activities because the survey was a census. If you talk to everyone, you don't have to do any work. That's just the answer. It's just not usually feasible to talk to everyone. All right, a compact disc manufacturer, CD, wanted to determine which of two different cover designs for a newly released CD will generate more sales. The manufacturer chose 70 stores to sell the CD. 35 of these stores were randomly assigned to sell CDs with one of the cover designs, and the other 35 were assigned to sell the CD with the other cover design. So random assignment, that's good news. That sounds like I can get some cause and effect. The manufacturer recorded the number of CDs sold at each of the stores and found a significant difference between the mean number of CDs sold for the two cover designs. Which of the following gives the conclusion that should be made based on the results and provides the best explanation for the conclusion? So the manufacturer chose 70 stores, right? So that doesn't mean random selection. So I wouldn't be able to make an inference about the population. However, the manufacturer did randomly assign the CD to with the two different cover designs. So we can get cause and effect, just not about a population. So if I read through these answer choices, the one that says I can have cause and effect is D. That's the only one. Oh, that's not true. D and E both say that. So A, B, C. I can get cause and effect. A, B, C are wrong. It's either D or E. D says that I can get cause and effect because of random assignment. E says because the sample size was large. Sample size doesn't give me cause and effect. D. The manager of a public swimming pool wants to compare the effectiveness of two laundry detergents, detergent A and detergent B, in cleaning the towels that are used daily. As each dirty towel is turned in, it is placed into the only washing machine on the premises. When the washing machine contains 20 towels, the manager flips a coin to determine whether detergent A or detergent B will be used for that load. The cleanliness of the load of towels is rated on a scale of 1 to 10 by a person who does not know which detergent was used. The manager continues the experiment for many days. Which of the following best describes the manager's study? Okay, so the manager did not break this into groups, right, before doing the random assignment. Just said, there are towels in this washer. This is the only washer. Random assignment. Okay, that's completely randomized design. It's like textbook completely randomized. That's it. A biologist is interested in studying the effect of growth-enhancing nutrients in different salinity levels in water on the growth of shrimp. The biologist has ordered a large shipment of young tiger shrimp from a supply house for use in the study. The experiment is to be conducted in a laboratory where 10 tiger shrimp are placed randomly into each of 12 similar tanks in a controlled environment. The biologist is planning to use 3 different growth-enhancing nutrients and 2 different salinity levels. List the treatments. So treatments, I need to think about factors and levels first. So I've got 2 factors, the growth-enhancing nutrient and the salinity level. The growth-enhancing nutrients have 3 levels, A, B, C, and the salinity has 2 levels, low and high. So I can go A, low, B, low, B, low, C, low, green, and then I can go A, high, B, high, and I can do C, high. And those are my treatments. That's all of them. I hit them all. If you want, you can make a little diagram. You can go A, B, C, low, high, that kind of makes sure that you don't miss anything, but either one will work. A biologist, oh, it's the same thing. Using the treatments listed in Part A, describe a completely randomized design that will allow the biologist to compare the shrimp's growth after 3 weeks. So the first thing I want to note, there are 12 tanks and only 6 treatments, right? So every tank, every treatment is going to be in 2 separate tanks. So let's note that each treatment will be replicated. All right, so we need to describe a study. So that sounds like a design diagram, right? So that's we're going to start with our 12 tanks. We're going to do random assignment. We need to describe that random assignment once we're done making this diagram. That was a mess, and that looks really bad. Kind of looks like a cell division. Anyway, random assignment. Let's do this. Let's assign each tank a number. Then we'll use a random number generator. Then we'll use the random number generator to generate 12 numbers from 1 through 12, so we're basically just getting a random list of the numbers. And we'll ignore repeats. The first two are low, then a high, etc. That would do it. There are many, many ways that you could do this random assignment. That's just the first way that came to mind while I was writing this. Whatever works for you. Give one statistical advantage to having only tiger shrimps in the experiment. Explain why this is an advantage. Okay, so an advantage would be that we're reducing sampling variability because we're only looking at one type of shrimp. This is an advantage because it gives us better estimates of the results. I don't want to use the word more. That's sufficient. Give one statistical disadvantage. Well, now I don't know what's going on with any other shrimp. That's it. So the experiment would have to be repeated for each shrimp type. Oh, we're done. Oh man. Bye.